How do you do? I'm Graham Murphy, a product manager here at Tech Rentals. Today we're going to look at the Torkel battery tester. For the sake of the simulation, what we've done, we've set up a little battery bank here. Now, I've got the specifications on these batteries. Now, what we're going to do, the assumption is that these batteries are going to provide 10 amps of loading for 1 hour. So we can draw 10 amps from this at 48 volts for 1 hour. So this is our simulation. Yep. Right, I'm going to now connect I connect these leads up to the Torkel, and now I'm going to connect them up to the battery. Okay, now here's my battery bank. I've connected the leads up here to draw the current from them. Now I also need to connect a few other leads. Now we have remote sensing on the voltage measurements, and we can measure the voltage on each cell. Now I'll go through, I'll now connect up the voltage sensing. Okay, here's our voltage sensing leads. So put those on there, so they're doing the sense. Okay, now I need to connect up the BVM, which is the voltage measurement module. So I'll plug this into the unit, the USB in here. And here's the BVM, here's the data output which I've plugged into the Megger, the Torkel down here. I've got a power supply for it. Now I've got to daisy chain my voltage measurements together. Okay, so if we take the first, here's the voltage out, so I'm going to clamp that on there. Now I daisy chain these measurements, so we take each of the battery units. So we connect these to the battery negatives. So I'll take that on there, that on here, that on here, and the last one on here. These have to be put in the right sequence because otherwise the display on the Torkel will be wrong. So they are daisy chained from the first one here. This connects to the first. They daisy chain first, second, third, fourth, all along the negatives until you find your final one, which is the one on positive here, is then chained back. Okay, now I've worked out from here, if I'm going to draw 10 amps for 1 hour, it says on this spec sheet that it's going to be 10.8 volts is the minimum cutoff voltage. So 4 times 10.8 is 43.8, 4 is 32, 43.2 volts. So that's our minimum cutoff if we're drawing the safe thing off the spec sheet. So that's going to be one of our cutoffs. Now look, turning the Torkel on, we just switch the on button. The fans kick up so it becomes quite loud. Now, if the emergency stop is pushed in, you can't start. Okay, so in other words, you've got to make sure this button is out. Now, to get it out, you've got to do a half twist on it. Now, the unit's still booting. Okay, we've now started the unit. It's found, it's looked for the BVMs, and that's all running happily, so it actually gives you the current cell voltages. You can see here that one of them is a little bit lower than the others. These are an old set of batteries. Anyway, just go back to our test setup. I've entered in this 43.2 volts because that happens to be, in this case, the minimum cutoff. Test time, we're going to run it for 1 hour. So we're going to, we'll stop the test after an hour. Now it's going to be a constant current drawn. Now we can actually set power, and you can set profiles up. You can do all sorts of settings here. In this instance, we're just going to draw a constant 10 amps. Now, once I push go, this you can see here. There's a figure here. There's no amps being drawn by this unit, and it's 50.7 volts it's supplying. Okay, so I've set my stop voltage. If the voltage drops below that, we know the test has failed, and it's going to last for 1 hour. Now we can come back over here. Now I just hit I close this with that constant current. Now we can enter that in if we want to enter current. We just click on that cell, click on that cell, we can enter those figures in, etc. Now we can also see the voltages over here. So now we hit the test start, So I'm going to hit start on this. Fans kick up, and here is the voltage graph as it's occurring. And here is the cells. Now we're drawing 10 amps according to the external current, and we can see how the test is going back here. There's the graph of it, and we now leave it for 1 hour, and we come back in an hour and see how it's gone. Okay, I've just realised that one of the things that's useful to do also, we're going to set an individual cell voltage of 10.8 volts because that's off the spec, so this is 4 times that. So if any individual cell drops, now I had to switch that on and enter that value in here. So I go OK on that. I pause the test momentarily. Now I'm going to hit start again, and that will continue the test. Now you can see that here's the red line. If any of the cells, individual cells, drop below that red line figure, the test will stop and it will have failed, and we'll know that it happens to be cell 3 in this instance. So here's the, and we've got the graph of our consumption. So we've got the rest of the duration, it's all going to run out. At the moment we've only run for a minute, and I've got a funny feeling our battery bank is not going to make it because we're actually already getting quite low there. Okay, as we can see here, the test was running, alarms went off, this thing started to beep madly. We've just paused the beeping so we can hear ourselves think, and we can see here cell 3 has failed. So we've managed to prove that this little battery bank was inadequate to the task, and cell 3 needs to be replaced. Simple as that. Now we can download results if we wish by plugging into a memory stick here, so we can get the graphs out and provide reports, etc. Very easy, very simple to set up piece of gear, extremely effective in telling you how well your batteries will survive failures. It's a good piece of equipment from Megger, Torkel. Thank you very much.